Welcome to Getting to Know Google SecOps. I'm John Stoner, and today we're going to take what we previously learned with statistical searches a bit further and look at additional aggregation functions and calculations that can be performed in UDM search to ask more complex questions of your data. We already discussed that statistical search is an expansion that goes beyond the tabular results set into aggregated data by common values and generating calculated values. This time we are going to use additional concepts like placeholder variables, aggregation functions, and mathematical operators that are part of YARA-L and apply them to our statistical search. If you've written YARA-L rules, some of these concepts may be familiar to you. As we build our search, you may look at how I build it and think there might be a different way to go ahead and approach this problem, and chances are you're probably right. There isn't a single way to achieve the same outcome, but we're going to show one method today, and you may uncover additional methods that you want to use, and that's great. Finally, there are a number of other YARA-L functions available to work with data, and we'll use a few of them today. Just know that there are additional capabilities that can be used when working with your data set. We're going to start where we left off in our previous video with Corelight TCP network connection events. This time, we want to generate a listing of the top IP pairs based on event count. One approach we could use would be to add both the principal IP and target IP fields to the match section. I'm going to use a placeholder variable called IP pair and the strings.concat function to combine these values into a single variable with a pipe to separate the two values. Additionally, my data has an annoying IPv6 address of : :1 on one of the servers. So after creating this placeholder variable, I'm going to exclude IP pair values that have this value in the field. From there, we can match on this new placeholder variable, and then, like we've done previously, generate an event count, sort by the count, and limit our results to 10 rows and run our search. Our results are the IP pair in the match section and the count from the outcome section. Now, let's use another aggregation function with our results. The aggregation function of sum will take all of the values in a field and add them up based on the aggregation value, in this case, our IP pair. We can add the sum of the sent bytes and another sum for the received bytes to our outcome section. Let's also adjust the order section to sort by the sum of the received bytes. Now in our results, we have 4 columns: the IP pair, the number of events that match this IP pair, and the sum of the sent and the sum of the received bytes between these two IP addresses. This is looking pretty good, but perhaps we want to add some sort of explanation for each row to denote something about our data, like, is this an internal only or includes external addresses? We could use the net.ipInRange_CIDR function to look at the IP address and return a Boolean value if the field matches the CIDR block provided. Because we have aggregated our results set, we need an aggregation function in front of our conditional statement, that is, the if-then-else statement. So we can prepend this entire statement with the aggregation function of array_distinct. In this case, if the principal and target IP addresses are both part of the provided net block, we want to go ahead and return internal only, and if not, we will return external. This provides us a nice summary of each pair with some key values. If we wanted to refine this further to provide additional granularity on the data flow, we could do that as well. While there is a directionality field in UDM, let's build our own to indicate if data is flowing between two internal addresses, or from outside to inside, or from inside to outside. This time, we have multiple conditional statements nested within one another. That is, if this, then that, else a new if statement, and so forth. When we run our search, notice our descriptive column now displays a few different outputs depending on the IP pair values. I realized I used the net IP and range CIDR function in the last two examples of this search. And some of you may be asking, yes, but what if I have a number of IP ranges I want to include in this search and they are non-contiguous? Could I do something similar? The answer is yes, with CIDR lists. We could construct a similar nested conditional statement using AND as well as NOT with the in CIDR net block list functionality. Notice that, like our previous examples, our conditional statements are nested within the aggregation function array_distinct. When we run our search, we get a similar result, but we are able to use more net blocks within our search. In our demonstration, we've highlighted how we can add placeholder variables and aggregation functions like array_distinct and sum to our search. It's also important to remember that there are multiple ways to achieve the same result, so there is not a single right or wrong method. It really goes back to what you're trying to accomplish. Finally, while we just use strings.concat and net IP and range CIDR, there are a number of additional functions that YARA-L makes available to us that can be used in search. Conditional statements, like if then else, can also be used, as well as mathematical operators within the outcomes section of our statistical search. In future videos, we'll be digging into more functionality, see what I did there, that is available to users in both search and rules, and we will be building some of these examples using statistical search to highlight the capabilities. I hope you'll check them out. If you want to learn more about Google SecOps, check out my blog series called New to Google SecOps for more handy tips. We have a number of community YARA-L detections at our GitHub site and are continually adding more. And don't forget to engage the security community at secopscommunity.com.